Okay, welcome to another edition of Sellers Review Notes. Haven't come up with a good intro song yet, still working on that. This is going to be just some classification of matter, different types of matter, and what constitutes matter. So, matter is anything with volume and mass. Volume is the amount of space taken up by an object. Be measured in two different things, milliliters or centimeters cubed. The milliliters be measured in a graduated cylinder. Centimeters cubed you can measure as solid length times width times height. But you can also drop the solid inside of a graduated cylinder with a set amount of water in it and watch the liquid jump up to whatever the new volume is, and that will be the volume of the solid. It's good for finding the volume of irregular objects like a rock or something like that. Mass is the amount of matter something's made of. Basically, how many atoms are in something. You're going to be made of the same number of atoms. If you go to the moon or if you're on the planet Earth, you're going to be made of the same atoms. Therefore, your mass will be the same. However, if you go to the moon, your weight will change because weight is mass times gravity. Because the moon has less gravity, you will therefore weigh less. So moving along here. Matter can be classified as a pure substance or a mixture. So we'll go into the pure substances first. Pure substance can be one of two things, either an element or a compound. We call them pure because they always have the same composition. Let's move on to elements. Elements, as you'll remember from the periodic table, we finished that unit. It's basically a substance that can't be broken down into simpler substances. Gold is oftentimes found with other types of rocks and metals with it, but once you break it down to the gold level, that's as far as you can break it down. It's just at the atomic level. Let's see. On the compounds. Compounds is just a mixture of at least two or more elements. Has to have at least two or more. That's why it's called a compound, just like a compound word, a compound sentence. It's a little bit more complex than just the element. It can be broken into simpler substances, but it's not easily done so. H2O, for instance, can be split into hydrogen and oxygen, but it's not very easy to do it. Sodium chloride is a little bit more difficult to break down to its elemental components, but it, technically can be done. Moving on to mixtures, you have two different types of mixtures. And mixture is two or more substances combined with the substance retaining some of their original properties. Two different types of mixtures. Heterogeneous and homogeneous, or homogeneous. Heterogeneous mixtures are the easiest type of mixtures, in my opinion. It's things like birdseed is a good example of a heterogeneous mixture. You can clearly see the different pieces of the different seeds. The key word here is noticeably different. Salad is a fantastic example because lettuces can be seen in this picture, as well as cucumbers and tomatoes, and these things are just very noticeably different. And the sand over here has different colored particles, different shapes, and so forth. Very easily detectable that they're different. Homogeneous mixture or homogeneous mixture. Tomato. The substances are so evenly distributed that it's difficult to pick one out. Good example of this is Kool-Aid. I love Kool-Aid. It's delicious. stains your mouth all the time. Kool-Aid, when it's mixed, is indistinguishable as far as you can't point out where a water molecule is and where a Kool-Aid particle is. They're so thoroughly mixed that it looks like it's one throughout. Same way with coffee. Coffee's so thoroughly mixed together that it's indistinguishable, which means you can't just pick it out like the salad. Liquids can be broken down further into solutions, suspensions, or colloids. When substances dissolve and form a homogeneous mixture that doesn't separate into layers over time, that's what we call a solution. It really just means it stays mixed up for long periods of time. Windshield washer fluid is a good example because it's usually windshield washer fluid sitting for months and months and months. It still won't bleed thoroughly whenever you look at it. Tap water is a good example because tap water has metals, and it also has chlorine and other additives in it, fluorine as well, fluoride. But these things are so thoroughly mixed together, you can't see them, you can't distinguish them. If you let them setting over time, it will not settle out. They'll just stay in the water. Suspensions are, I think, the easier of the liquids because it's again a heterogeneous mixture. Heterogeneous mixtures are always easy because you just look at it and say, oh, this is a mixture of this stuff and this stuff up here. And salad dressing is a great example, especially an Italian dressing or some kind of dressing that has oil and water in it. The oil typically settles to the top pretty quickly, actually, and the water with the other stuff in it stays at the bottom. And before you serve, of course, you have to shake it. Medicines are also in suspension, which is why it's very important to follow directions when it says to shake well before use. Because a lot of times some of the medicines will suspend down to the bottom, and you don't get the full dose of the medicine if you don't shake it. Last type are colloids. Colloids are kind of a weirdo in between. It's not quite a suspension, it's not quite a solution. It will not separate into layers, so in that way it's like a solution. Milk was a good example. Milk will stay white, for long periods of time, but it will scatter light like a suspension, which means that the particles in it are big enough that they can't typically be distinguished, but you can see that they scatter light. It's a glass of water on the right side, water being solution, the light goes straight through it. Particles are so well mixed together in the water that they are not interacting with the light. Light passes straight through it. This is a glass of gelatin, or Jello as you know it, and the Jello will reflect the light from the laser beam, as you can see here. And I think that's, we're going to stop it. See you in class.